The masses of the strange quark and the muon are attributed solely to the generic down quark and the generic electron assembly constituents of these particles. It is suggested that this initial mass originates entirely from the combinations of the associated Rishon fundamentals, which also form the space-time networks. The 6 Rishon fundamentals, represented by the letters A through F, may be partitioned into 2 Rishon expressions basis groups, A, B, C, and D, E, F. These are termed basis groups because the combinations between them will be the basis for the 48 plus 48 equals 96 expressions that compose the space-time structure of the local extensions of quarks and leptons. Given 6 Rishon fundamentals, basis groups can be configured in 20 different ways, giving rise to 10 different ways of partitioning the 6 Rishon fundamentals. Each fundamental may participate in 10 of the basis groups. In other words, 10 times 20 different permutations of the basis groups through which each fundamental may express in the basis groups. I term these permutations of the basis groups the multiplexity of Rishon expressions. The transactivity of the particularity and the multiplexity impulses the inertial and kinetic transitions of Rishon expressions. Each T group or T expression will multiply or divide the 20 permutations by 1 or 10, depending on the combinatorial configurations of the expressions. Rishons composing generic quarks and leptons can have, as previously stated, a mass factor of 1 or a mass factor of 10. And this factor will depend on the combinatorial configuration of the generic quarks or leptons. Rishon fundamentals, when they combine, always produce a T and V doublet, and then to form a quark would necessarily combine with the T of another doublet, thereby creating a generic U quark. But in the case of the D quark, the anti-T, anti-V doublet will necessarily combine with another anti-V Rishon expression of another doublet. For any given Rishon fundamental included in a basis group of 3, there will be produced 2 T Rishon expressions. If the 2 T Rishon expressions appear in the same generic quark or lepton, they will provide a mass factor of only 1. But if they appear singularly in a quark or lepton composition, they will provide a mass factor of 10. So in the case of the D quark, there is a single anti-T Richine expression providing a mass factor of 10. So the initial mass of the D quark will be 10 times 20, which equals 200 electron units. But in the case of the U quark, 2 quarks express different Richine fundamentals of a basis group, and therefore each provides a mass factor of 10, giving mass factors of 10 times 10 times 20, which equals 2,000 electron units. Now, in the case of the generic electron, 2 of the anti-T Richine expressions represent the same fundamental of a basis group. So the mass factors are 1, and 1 times 1 equals 1. But the third anti-T expression singularly expresses another fundamental of the basis group. So its mass factor will be 10, therefore giving us 1 times 10 times 20 equals 200 electron units. So in this way, depending on the combinatorial configurations expressing the permutations and combinations of the Richine fundamentals, we get the initial masses of the generic quarks and leptons, and thereby the initial masses of the middle generation particles. The masses of the strange quark and the muon are attributed solely to the generic down quark